Okay, just comment number 43. It's a great problem. I love the problem, and your solution is just fine. It came out just fine. But the problem in the text, I just can't let it pass. And I put myself in line here. Either the statement is incorrect, or I don't understand rotational physics, which I've been teaching for hundreds of years. Okay? It says that angular velocity omega equals AI plus bj plus ck, and I'm not sure it used A, B, and C. What letters did it use? Yeah, it did. I think it did. Yeah. Okay. Standard letters. I claim this is not rotation about the z-axis. Okay? It's rotation about the vector AI plus bj plus ck. Okay? Rotation about the z-axis. I get these demonstrations I use in physics all the time. If this is rotating here in the xy plane, then the right-hand rule tells you that the axis of rotation is perpendicular. It's the only axis that makes sense. There is no vector other than a vector perpendicular to the plane in which the thing is rotating that makes any sense. Any vector in the plane would have to change as the rotation continues. And clearly what I demonstrated there is rotation about this axis. Something rotating about this axis is doing this. And the axis would just be k. So this is rotation about this axis. Now let me see if I can talk myself out of that. Nope. The direction of the vector rotation is the direction of the axis. Okay? And we don't care if it's clockwise or counterclockwise. It makes no difference. And let me use, okay, yeah, at a point. At the point xi plus yj plus zk, it's true what the book says, the velocity is on this point R now I'm into something I could have gotten backwards. Okay? So if you're rotating in this direction, that at this point, the velocity is in this direction. Okay? So omega is up here, and R is out here. So if you do omega cross R, you get this direction. So that seems to work. That's how you check it out. Okay. So, yeah, I could look at the formula or just memorize the formula. I don't like to do that. I like to think things through. Not that I can't, well, yeah. Originally it wasn't that I couldn't memorize things. Now at my age, maybe I can. So I've got to go back to common sense. Okay, well that's just total irrelevant digression. Okay? Velocity is omega cross R. And so this gives you a velocity field. The velocity, it's a function of x, y, and z. And you easily prove that the divergence of the equals 0, identically, and the curl of V is non-zero, and you get an expression. It's I think 2AI plus 2BJ plus 2CK. And that's always non-zero as long as V isn't 0. And the only way V is 0 is if R is 0, meaning you're on the axis. Also, this seems to imply rotation about a point. I don't want to think about that right now. Okay, so I think I'm wrong about that. Anyhow, this is easy to prove, and it's basically just, you know, this axis is, you know, here you got your X, Y, and Z coordinate system. And I think you do need to say rotation about an axis through the origin. Okay, so here you got your axis through the origin. Parallel to AI plus BJ plus CK, then you got this thing rotating about this axis. Okay? So at point, and let's just just to give this a little more meaning, I'm going to draw a few projection lines to show a point on this axis in the origin, so we get kind of an idea of its direction. I'm probably going to have trouble depicting this. Let's see what's a good convenient point to use. Point xi plus yj plus zk. I'm not going to try to depict it. Okay. All I'm saying is it's not a rotation about the z-axis. Okay. That would be rotation about an axis through the origin.